Chapter 11, Section 2, Day 1 starts probability, and this one specifically talks about experimental probability. An experiment is an activity involving chance. So anytime you do something or try something and you're not entirely sure what the outcome would be, that's called an experiment. Every time you do it, it's called a trial, and each result of that trial is an outcome. So if you flip a die, flipping a die is an experiment because you don't know what you're going to roll, and every time you actually roll it, it's called a trial, and what you get, if you roll a 6, if you roll a 2, that's called an outcome. All of those outcomes together is called a sample space. So the common experiments that this course talks about is dice, coins, and spinners. Experimental probability is based on repeated trials of an event. So what happens over and over and over again. It's not based on what should happen, it's based on what has happened. Probability is an event. Probability of an event is the chance that it could occur. It has to be a number from 0 to 1. It can be written as a fraction, a decimal, or a percent. If an event can never occur, we say the probability of it occurring is 0. So some events that could never occur are things like rolling a number greater than 6 on the die, because only numbers 1 through 6 are there. Or naming a month with an X in its name, because none of the months have an X in its name. If the probability will always occur, we say that it's 1, the chance of it happening every time. So some events that have a probability of 1 are rolling a number less than 7, because all of the numbers are less than 7. Or naming a day of the week with an A in its name. Experimental probability is found by doing the number of times the event occurs over the number of trials. So we also talk about this being favorable, and this being the total. Number 1, Mike was doing an experiment in which he tossed a coin 200 times. He recorded 112 heads. What is the experimental probability of? Letter A wants heads. So the probability of heads is found by doing the number of times he flipped heads over the number of times total. So he flipped heads, according to the problem, 112 times. And he flipped a coin 200 times total. So all you need to do is reduce. Letter B, they want the probability of tails. That means we're looking for the number of times tails comes up over the number of times total. Mike flipped the coin 200 times. And of those 200 times, 112 of those were heads, which means that 88 of those would have to be tails if you subtract. And if you reduce 88 over 200, you get 11 over 25. Number 2, a basketball player attempted 24 shots and made 13. Find the experimental probability that she will make the next shot she attempts. So I'm looking for the probability that she makes it. That means I'm looking for the number of makes over the total. It said she attempted 24 shots, so that's her total, and she made 13 of them. So the answer is 13 over 24. Cannot be reduced. Number 3, a lodge inspects 80 skis and finds 4 to be defective, broken. What is the experimental probability that a ski chosen will be defective? So I want the probability that it's defective. And it does say written as a percent. So I'm looking for defective over total. It does say that there are 4 to be defective, and there are 80 skis total. So in the calculator, do 4 divided by 80 and move it 2 places to get a decimal and percent. You get 5%. It's a 5% chance it's defective. A softball player got a hit in 20 of her last 50 times at bat. What is the experimental probability that she will get a hit in her next at bat? So we want the probability of a hit. That's hits over total. They do want it written as a percent. So the number of hits she got was 20, and she tried it 50 times. Written as a percent is 40%. An experiment consisting of randomly choosing a marble from a bag. What is the experimental probability of? So before I start this, I'm going to actually count them up. There are 3 yellows. There are 3 reds, 2 blues, and 3 greens. So overall there are 11 total. All right, letter A, choosing a yellow means I'm looking for yellow over total. There are 3 yellow and 11 total, 3 over 11. Letter B, choosing a blue means I'm looking for blue over total. There are 2 blue, 11 total, 2 over 11. Letter C, choosing a purple means I'm looking for purple over total, but there aren't any purple, so it's 0 over 11, or 0. That can never occur. And letter C, not choosing a green. So on the top here, we want not green. On the bottom is total. The not greens are yellow, red, and blue, and that's a total of 8 over 11 marbles in the urn makes 8 over 11.